Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khurram and in this channel I teach programming skills in Python, MATLAB or R programming. I also teach theoretical concepts as well as practical programming skills in data analysis, data science, statistical analysis or machine learning. So if you are a person who wants to learn programming from scratch or you are a person who wants to excel his career in data science, I request you to subscribe to my channel. As I have stated earlier that I am going to produce a series of video regarding statistical analysis in Python. So in today's lecture, I'm going to discuss about correlation. What is correlation? How we can actually exercise that concept of correlation by the help of Python programming. So we are going to discuss about Pearson correlation coefficient, which is for linear relationship. Then we are going to discuss about Spearman-Rand correlation coefficient, which is for nonlinear relationship. Then finally, in the upcoming video, I'm going to discuss about marketing analytics case study, where I will also use pandas library to create data frame and then perform statistical analysis. So let's move on and actually discuss about correlation. What is correlation in statics? So correlation is a statistical technique used to measure and describe the strength and direction of the relationship between two variables. It helps us understand how changes in one variable are associated with the changes in another variable. So there are two types of correlation. First of all, we have positive correlation. When the values of one variable increases, the value of other variable also tend to increase, and vice versa. That is, when one variable decreases, the other variable also tends to decrease in our data set. So that type of correlation is called as positive correlation. Then we have another type of correlation that is called negative correlation. When the value of one variable increases, the value of the other variable tend to decrease and vice versa. And finally, there is a situation where we say that there is no correlation at all between the two variables. In that case, when there is no apparent relationship between the two variables, the changes in one variable do not affect the other variable. So we have three types of correlation: positive correlation, negative correlation, and one where we don't have any correlation at all. We call it zero correlation, which is approximately equal or quite close to zero. So let's move on and actually exercise those concepts in Python programming. I know all of you are interested in how we can actually exercise those concepts in Python programming, because we want to improve our Python programming skills, and specifically in statistical analysis. So where we are able to conduct statistical analysis with the help of Python programming. So first of all, I'm going to import our important libraries. First of all, I'm going to import NumPy library by using this Python statement, import NumPy as NP. NumPy library is quite of an important library in Python, where we actually help us perform certain numerical operations, and also help us to do manipulations or operation using arrays. Then we have pandas library. I'm going to import panda library by using this Python statement, import pandas as PD. So panda is again very important library for data analysis or data manipulation. And finally, I'm going to import the module pyplot from the library matplotlib, and I'm calling it using it as alias as plt. So whenever I need to call this module, I'm going to call it by the help of this alias plt instead of referring back to the whole matplotlib.pyplot. So I'm going to import this module by using this Python statement, import matplotlib.pyplot as plt. So once we have imported our necessary libraries, let's move on and actually first of all generate the data from which we can actually calculate the correlation. Then we will plot the correlation, we will plot the generated data, and finally we will calculate the correlation. So let's move on and actually move towards how we can actually generate data for our experiment. So in this case, I'm going to take help from NumPy library. First of all, I'm calling this method numpy random.seed, and I'm passing input argument as 0. This Python statement here help us ensure that whenever the script is run again and again, we will have the same number of values generated irrespective of how many times the script has run again. So we will have the same number of same type of random number generated. So it is useful for reproducibility, where you want to actually show the same result to other people as well. So I'm setting the seed of random number generated here, np random.seed here. Let's move on and actually generate an x and y values, so we can actually calculate the correlation and also plot these values using a scatter plot. So for x values, I'm going to initialize a variable named x, and I'm going to create it by passing by calling the method here rand of the numpy library from this module random. So we have here, I'm using np random.rand, and I'm passing input argument 100. This will give me 100 random values between 0 and 1. So by using this Python function here, I'm able to get 100 random values between 0 and 1. So this is, in our case, is an independent variable. Now let's move on and actually work on generating dependent variable, which in our case is y. So in that case, I'm initializing a variable named y, and I'm equating its value to x, plus I'm adding some random noise to it that follows a normal distribution. This function here, np random.normal, actually generates a random set of values, and it takes 3 input arguments. You can see that 0, 0.1 and 100. The first input argument actually represents the mean of the normally distributed series. Okay, so in our case, we settings mean is equal to 0. Then the second input argument is actually the standard deviation. What will be the standard deviation of the normal distribution? In our case, we are setting it to 0.1. And finally, 100 represents the number of elements we want. What will be the number of elements in this randomly uniform distribution? In our case, we want 100, so which is again the same number of values we have generated for x. So basically what we are doing, we are just equating y equal to x with some added noise. So with this randomness added noise will help us ensure that our data set might closely match to the real world scenario, where there is always a short of degree of randomness or error in the points. So this is how we actually created a dependent relationship where y is equal to x plus some added noise. Once we have generated our data for linear relationship, let's move on and actually plot those values. In order to plot those values, we are going to simply use this scatter function here, that which help us plot the values between x and y. We will use plt.scatter function, and we will pass 2 input argument. The first one input argument will be the x values, and the second input argument will be the y values. So it will create the scatter plot of the pair values from the x and y. Then by using this Python statement here, plt.title, I'm setting the title of the scatter plot. Title help us give us context to the plot, what is this plot is all about. So I'm setting the title by using this Python statement. In the similar manner, I'm setting the label of x-axis and y-axis by using these 2 Python statements here. plt.xlabel within those curly braces, square round bracket, I am using passing x string as an input argument. So it will set the label of x-axis as x string, and in the same way it will set the label of the y-axis as y string. And finally, I'm going to use this function plt.show that will actually render the plot in the Python environment. So once we have done that, let me just run this block of code for you so you can actually understand that. First, I'm going to import our necessary libraries. Then I'm going to generate the data of dependent and independent variable x and y. Once I have done that, let's move on and actually plot this value by the help of scatter plot. And now you can see that its values are generated, and we have like on x-axis we have x values, and y-axis we have y values. And you can see from the plot that it tends to follow a linear relationship. As the value of x increases, the value of y is also increased. So this is again a linear relationship we have created by simply equating y is equal to x by adding some random normally distributed noise to it. Once we have done that, let's move on and actually calculate our Pearson correlation coefficient. The Pearson correlation coefficient, often denoted as R, is the measure of linear relationship between 2 variables. So remember that Pearson correlation coefficient is always calculated when we have a linear relationship. It ranges from -1 to 1, where R is equal to 1 indicates a perfect positive linear relationship, and r is equal to -1 indicates a perfect negative linear relationship, and when we have r is equal to 0 indicates no relationship between the variables. And you can actually correlate this, or you can also relate this definition and the values of -1, 1 and 0 to our earlier definition of types of correlation, where we have positive correlation, negative correlation, and zero correlation, which means no correlation at all. So let's move on and actually calculate our correlation. So in order to calculate the person correlation coefficient, first of all, I'm going to initialize a variable named correlation underscore coefficient, and I'm going to create it by using this Python numpy function here, np.core-coefficient, and I'm passing the two input arguments x comma y, so we can actually calculate the correlation between these two values. So this np.correlation coefficient x comma y actually returns us a matrix of 2 by 2, and in order to extract the correlation coefficient value out of this 2 by 2 matrix, we are going to assign its position 0 comma 1. This is where we have actually the position of correlation coefficient. So it will, first of all, this Python statement here will calculate the will return us the matrix, and out of this matrix our desired correlation coefficient value lies in this position here, 0 comma 1. So by using this Python statement, we are able to calculate and extract correlation coefficient value by using this Python statement of numpy function here. So once we have done that, we are simply going to print its value by using the simple print function with a descriptive message person correlation coefficient. So let me just run this block of code for you. So now you can see that our correlation coefficient is quite high. It is quite approximately equal to 0.944. So we can say that these two x and y are highly correlated, and they have a positive correlation. Now, as we have discussed about the linear relationship, let's move on and discuss about non-linear relationship. Because obviously, in a real scenario, in practical scenario, we do have variables where they don't follow a linear relationship. In that case, they follow non-linear relationships. So in order to calculate the non-linear relationship, we have another correlation coefficient, which I'm going to discuss in a moment. So first of all, in the same way as we have for the linear relationship, we have generated data. So in the same way, we are going to generate data, and we will generate x and y values, where the x and y values are non-linearly related. So you already know the purpose of np_random.seed, which sets the seed for random number being generated, and it will give us the same number of random number generated irrespective the code has been run many times on some other computer as well. So once setting the random seed of randomly number generated, let's move on and actually create our x value. So in order to create the data set of x, we are going to initialize a variable named x, and we are going to use this method here, np_random.rand, and I'm passing 1000 as an input argument. With this will ensure that I'm getting 1000 random values between 0 and 1. But I'm also multiplying it by 150. It means that we are scaling our results to 150 times. So the values will lie between 0 to 150 instead of 0 to 1. So once we have created an independent variable, let's move on and create our y variable, which is the dependent variable. If you recall that for linear, we actually just simply set it to y is equal to x. But in our case, now we want instead of linear relationship, we want non-linear relationship. A quadratic relationship can also be a non-linear relationships, and that's what we have actually done here. So if you look at this initial character of this Python statement here, y is equal to 0.5 multiplied by x power 2 minus 2 multiplied by x plus 3. So this is a second order polynomial relationship of y with respect to x, where the polynomial relationship is described such that we have a quadratic term here, 0.5 multiplied by x power 2, and then we have minus 2 multiplied by x as linear relationship. Then we have finally a constant. So that's how we actually created a polynomial non-linear relationship between x and y. And then we also added some random noise to it, so we can actually depict that data as a real world scenario. So we are going to use this method here, np_random.normal, that will create random numbers that follow our normal distribution. And we are passing three input argument. The first input argument is the mean of the normally distributed distribution. Then we have 200 as the standard deviation of the normal distribution, and finally we have the how many number of times, how many data points we actually want. In our case we want 1000 values that might be added element wise to the x values. So in our case, this is how we actually created a second order polynomial relationship with added some noise. So once we have actually generated our x and y values, let's move on and actually plot that x and y values with the help of scatter plot. So a new few addition to the previous code here. First of all, we have used this Python statement plt.figure fig size 15,5. This Python statement help us ensure that we are getting the plot of our desired size, where 15 represents the width of the plot and 5 represents the height of the plot, which are described in inches. So by setting this value, we are actually presetting the plot space for our figure, where the width should be 15 and the height should be 5. So after we have done that, we are going to use plt.scatter x comma y to plot the scatter values of x and y, and we are passing some additional input argument to this function here. So first of all, s is equal to 20. This s is equal to 20 represents the size of the points we are currently plotting on the scatter plot. So by default, the size of the points is actually less than 20. So by setting our custom size, we are actually making the points appear a little bit bigger. Then we have edge color is equal to black. This actually sets the edge color of the points to black, which will again will make the points more visible in the scatter plot. So we are passing two additional input arguments as compared to the previous code where we only use x comma y as an input argument to this function scatter. Then finally, I'm going to label x and y axis, and I'm also going to title our plot by using these Python statements here. Finally, I'm going to use this method plt.show to actually that will actually render the plot in the environment we are currently using. In the case, we are using Jupyter Notebook. So let me run this block of code for you. So now you can see that the relationship between x and y is non-linear. It follows some polynomial, second order polynomial relationship. And we have where the data being, and you can see that the values are being the noise is being added here. You can see that all the data points doesn't lie on a single line. Their noise actually help us visualize that the data set is actually distributed over some mean value and standard deviation. So we can see that this data point here 0 at the very end, it represents the standard deviation of 200 and 200, and all the data points are below this standard deviation or at this standard deviation. So once you visualize that, let's move on and actually calculate the correlation coefficient. The correlation coefficient in our case we are going to calculate is Spearman rank correlation coefficient. Spearman rank correlation coefficient assesses how well the relationship between two variables can be described using a monotonic relationship. It is based on the rank of the data values rather than the actual data values themselves. Spearman correlation coefficient is suitable for both linear and non-linear relationships. So we can actually use it for both purpose, for linear and non-linear relationship, but it is advisable to use it for non-linear relationship instead of using Pearson correlation coefficient for non-linear relationship. So in order to use the correlation, in order to calculate the correlation, I'm going to import this method Spearman R from this module stats of SciPy library. I'm going to use this Python statement in order to import the method or function here. So from scipy.stat import Spearman R. Once we have imported our library, we are going to calculate the correlation coefficient by using this function here, and I'm passing two input argument x comma y. Now this function here will return two variables. The first one will be the correlation coefficient, and then the second one will be the p-value. So what is p-value? I will describe about the significance of p-value in hypothesis testing in a separate video. I will put down the link in the description for you, so you can actually get an idea about what are p-values, what are hypothesis testing, how we can actually test hypothesis by using p-value. So in that right now, just simply visualize that it help us identify how significant is the relationship between these two values are. So if p-value is less than 0.005 or is quite close to 0, we say that the relationship between these two values are quite significant, and the correlation is quite significant. So first of all, I'm going to initialize two variable name, correlation coefficient, comma p-value. Then I'm going to create this value by using Spearman x comma y. Once I have calculated the correlation coefficient, Spearman rank correlation coefficient, and its p-value, I'm simply going to use print function to actually print this value with a descriptive name message. Now you can see that the Spearman rank correlation coefficient is 0.991, which is quite close to 0, and the p-value in our case is 0. It means that is less than 0.05. So we say that this correlation coefficient is quite significant, and there is a strong correlation between x and y, which is obvious because we already set y is equal to some value of x. In our case, it was a second order polynomial with y's. That's it for this video now. I hope this video has been helpful. If you have any questions, feel free to write down your question in the comment section below. I will be happy to help you out. In the upcoming video, I will take a data analytics case study where I will take data from the marketing analytic case study. And we using that marketing analytic case study, we will calculate the correlation coefficients of our data from the data frame. So you can actually get hands-on exercises with those kind of scenarios. So that's it for now. I will catch you soon in the next video.